Okay, this is page 4 of the communication notes, and we're just going to look at the implementation of double buffering. And as I said on the previous page, the producer and consumer must use the buffers in the same order. And now we're going to have two buffers, so let's allocate those. These again would be globals. Okay, so the size again will be const uint 32 type. We'll call it buff size. This is the size of the individual buffer. We'll make it 512 bytes, same as last time, and then we'll allocate an array of the buffers. And since we're talking in terms of bytes, we'll use uint 8 type buff, and this time it's a two-dimensional array. So two buffers of buff size each. Okay, and then we've got our hypothetical semaphores here. Empty is initialized to 2, full is initialized to 0, and these semaphores really just stop the consumer from catching up to and overrunning the producer, or the producer from catching up to the consumer and overrunning it, so like filling buffers that haven't been emptied yet. And so we've got our producer on the left, our consumer on the right, and we need an index, and the index will be initialized to 0. Same for both of them. They're going to start with the first buffer, and the producer has an infinite loop, and it needs to wait on empty. And so there are two empty buffers, so we'll be able to do this twice before the consumer needs to have emptied any buffers for it to continue. So it will write to the buffer at our index value, in this case 0, and then it will signal full. So the producer, assuming that it's already running, will have blocked on the full semaphore. This will unblock and it will go ahead and start consuming the first buffer, buffer 0. And I'm not going to add the extra text to this about producing the data. Let's assume that it's producing it either before it waits on empty or while it's writing to buffer. But the other thing that we need to do is we need to move the index along. So the index will be equal to, let's do it this way, index plus 1 mod 2. And I could have just said index equals not index or 1 minus index. That would also work. But this will generalize better when we move to n buffers instead of just 2 of them. There, so that's the producer. And for the consumer, I'm just going to say C problem set 6. Problem set 6. Okay, now there's still a bit of a limitation to double buffering. And it's that you're counting on the producer and the consumer filling and emptying their buffers at roughly the same rate. So the producer and consumer must use the buffers at the same rate. So if you have a producer that's kind of bursty, like it can produce a lot of data quickly, but then it waits a while, that's not going to be so good here, because it can only fill one, maybe two buffers before it needs to start waiting for the consumer. So the general solution is to have n buffers, where you can figure out what that number should be for your application. The producer can fill a bunch of them and wait for the consumer to catch up. So that's next.